They're all structural, wood ceiling, and wood beams, and wood columns.
One great thing about bamboo is it's technically a quite sustainable material.
For thousands of years, people believed wood would always be the main material for building. It helped create homes, bridges, cities, and even great civilizations. But what if that is slowly changing? China has developed a new type of engineered bamboo that is making many engineers look at construction in a completely different way. Some experts believe it could change the future of building, while others are still waiting to see the results. Could this be the material that finally replaces wood? Join us in this video as we discuss the details. China just replaced wood with this. Engineers can't believe it. For thousands of years, people looked at wood as one of the best materials for building almost everything. It was used to build homes, ships, bridges, barns, and many other structures. If people wanted to build something strong, they usually looked for trees. That way of building stayed the same for a very long time. People trusted wood because it was strong, easy to cut, and easy to shape into many different forms. Generation after generation continued using it because it had already proven that it could last for many years. But as time passed, one very big problem became harder to ignore. Trees do not grow quickly. A tree that is good enough for construction may need between 25 and 75 years before it becomes large and strong enough to use. That means a tree planted today may not help builders until many years later. By that time, an entire generation may have already grown up. As cities became bigger and the world's population continued to grow, the demand for building materials also grew much faster than before. More people needed homes, more roads were built, more schools, hospitals, offices, and bridges were needed. The demand became so great that waiting decades for trees to grow was no longer enough. Builders needed materials that were ready much sooner. Because of this, many construction companies depended more and more on steel and concrete. These materials could be produced much faster and in much larger amounts. They helped cities grow at a faster speed. However, they also created another serious problem. Allegedly, producing steel and concrete releases huge amounts of carbon dioxide into the air every year. This pollution has become one of the biggest concerns for people trying to protect the environment. For many years, it seemed like builders had only two choices. They could either use natural materials that were better for nature but took many years to grow, or they could continue using industrial materials that were faster but created more pollution. It looked like there was no middle ground. Then attention slowly turned toward a plant that had been growing quietly for thousands of years. That plant was bamboo. Many people think bamboo is a tree because it grows tall and looks like one from a distance. But bamboo is actually a type of grass. This simple fact surprises many people. Even though it belongs to the grass family, bamboo can grow much taller than a person and can become very thick. What makes bamboo even more special is how quickly it grows. Allegedly, some kinds of bamboo can grow more than 1 meter in a single day under the right conditions. That speed is almost impossible to imagine. While a tree may need many decades before it can be cut down for construction, bamboo can reach full strength in only 6 to 9 years. That difference completely changes the way people think about growing building materials. There is another reason bamboo attracted attention. When people cut down a tree, the tree is gone forever unless another one is planted. Bamboo works very differently. Cutting the stalk does not affect the plant. The roots stay alive underground. After some time, new bamboo shoots grow back from those same roots. There is no need to plant new seeds every time bamboo is harvested. This allows the same land to keep producing new bamboo again and again. That makes bamboo a renewable material that can continue growing for many years. Bamboo is also naturally very strong. Allegedly, when its weight is compared with its strength, bamboo can perform even better than steel in some pulling tests. It is also stronger than ordinary wood in several ways. For thousands of years, people across many parts of Asia used bamboo to build houses, fences, walkways, bridges, boats, and scaffolding. Even today, workers in some places still climb bamboo scaffolding while working on very tall buildings. That shows how much confidence many builders have in its natural strength. But even with all these impressive qualities, bamboo never became a common material for modern cities. It had several problems that engineers simply could not ignore. Every bamboo stalk is hollow inside. That makes joining pieces together much harder than joining solid wooden beams. Bamboo is also round instead of flat, making it difficult to fit into modern building designs. Another problem is that not every bamboo stalk is equally strong. One stalk may carry heavy weight without any trouble, while another stalk from the very same plant may not perform as well. That lack of consistency worried engineers because buildings must be safe every single day. Bamboo also has another weakness. When nails or bolts are pushed into it, the stalk can split apart. If it is not treated properly, insects may attack it, and moisture may cause it to rot over time. Yet, behind the scenes, researchers were beginning to ask one simple question that would eventually change everything. Instead of trying to force bamboo to behave like wood, what if they completely changed the way bamboo was made into a building material? Let's delve deeper. How bamboo became strong enough to build towers and bridges. The question slowly began to change the way many researchers looked at bamboo. Instead of trying to cut bamboo into boards like ordinary wood, they decided to break it down completely and build it back up in a new form. This simple idea changed everything. The bamboo stalk was no longer treated as the finished product. Instead, it became the raw material used to create something much stronger and much more reliable. The process allegedly started by crushing whole bamboo stalks until they separated into long, thin fibers. This stage is known as fiberizing. Once this happened, the bamboo no longer looked like a tall green stalk. It became a large pile of loose fibers that looked more like rough straw than wood. At first glance, it did not look useful at all. However, this step solved many of bamboo's biggest problems. The hollow center disappeared because the original shape no longer existed. The round outside also disappeared. The weak and strong parts became mixed together instead of staying in separate stalks. The material became much more even. After the fibers were prepared, workers allegedly dried them carefully to remove unwanted moisture. They were then soaked in a special resin that helped bind every fiber together. Once coated, the fibers were placed in the same direction before being pushed into large machines. These machines applied very high pressure together with heat. The pressure squeezed out most of the air trapped between the fibers and packed everything tightly together. When the process was complete, the result looked nothing like ordinary bamboo. It became a solid block known as bamboo scrimber. This engineered material was far stronger and much more dependable than natural bamboo. It was also much harder than many common hardwoods used in construction. Allegedly, tests showed that this material could handle extremely heavy loads and resist bending far better than many people expected. Another important advantage was that very little of the original bamboo was wasted. Around 80% of every stalk could reportedly be used during production, including pieces that would normally be thrown away because they were bent or uneven. This made the manufacturing process much more efficient. Although many people believe engineered bamboo is a new invention, the material has actually existed for several decades. Allegedly, one of the first high-strength versions was developed in China in 1987 at Nanjing Forestry University. Since then, researchers have continued improving the material little by little. The science kept moving forward, but widespread use remained slow because one major problem still stood in the way. Every new building material must pass strict safety tests before it can be used in schools, hospitals, offices, bridges, and tall buildings. Allegedly, nearly 7,000 research papers were published during the 10 years leading up to 2024. Every new study added more knowledge about its strength, durability, and long-term performance. As more evidence became available, confidence slowly increased. Engineers finally began using engineered bamboo in projects that many people once believed were impossible. China reportedly built what is recognized as the world's first 7-story building made mainly from engineered bamboo. The structure was not simply decorated with bamboo. Its columns, beams, and floors were built using engineered bamboo products designed to carry real structural loads. In 2022, China and the International Bamboo and Rattan Organization reportedly launched the bamboo as a substitute for plastic initiative. The following year, China introduced a national plan aimed at increasing the use of bamboo as an alternative to materials that produce higher carbon emissions, including steel and concrete. Demonstration areas were established to encourage industries to produce more bamboo products and prove that large-scale manufacturing could succeed. Allegedly, China now holds about 1/5 of the world's bamboo resources and has developed a complete industrial system that processes bamboo from forests into finished structural products. Reports also claim that the country's bamboo forests naturally absorb and store around 300 million tons of carbon every year. The industry has set ambitious goals, with plans to continue expanding over the coming years. Interest is also spreading beyond China. New companies are reportedly appearing in countries such as the United States, India, Indonesia, Vietnam, Singapore, and parts of South America. Even with all this progress, experts continue to point out that engineered bamboo is not without challenges. The material depends on special resin to hold its fibers together, meaning it is no longer completely natural. Researchers are still studying how it performs during major fires, how well it lasts after many decades of use, and how the resin should be managed when buildings eventually reach the end of their lives. Manufacturing also requires expensive factories, powerful machinery, trained workers, and careful quality control. Countries that have large amounts of bamboo but lack industrial equipment cannot immediately begin producing certified structural materials. Building regulations also continue to develop slowly because public safety always comes first. Even so, the progress made so far has surprised many people. Before engineered bamboo could become part of the future, one important question had to be answered. Why did America choose wood, while China placed its trust in reinforced concrete? Stay tuned for more. Why America and China chose different ways to build homes. For many years, people have looked at houses without thinking about what is hidden inside the walls. They see the paint, they see the windows, they see the roof, they see the doors. But very few people stop to ask one simple question. What is actually holding the entire building together? That question may sound small, but it tells a much bigger story. It tells the story of how two of the world's biggest countries ended up choosing completely different ways to build homes. One country trusted wood, the other trusted reinforced concrete. Those choices were not made because one country wanted its buildings to look different from the other. Allegedly, those decisions were shaped by history, by the land, by disasters, by money, and by the lessons each country learned over many years. In the United States, the story started long before modern cities appeared. It began when families were moving into new land and trying to build homes as quickly as possible. During those years, forests stretched across huge parts of the country. Trees seemed to be everywhere. They covered the land in almost every direction. People who wanted to build homes did not have to travel far to find building materials. The wood was already there. In many cases, the trees had to be cut down anyway before crops could be planted. That meant the same trees standing in the way of farming also became the walls, roofs, and floors of new homes. It solved two problems at the same time. Families cleared land for farming, and at the same time they gathered the materials needed to build a place to live. That made wood the easiest choice. It was simple. It was close by. It was available in large amounts. It also cost very little compared to many other materials. As more people settled across the country, builders wanted an even faster way to build houses. Allegedly, everything changed in the early 1800s when a new building method was introduced. Instead of using large pieces of timber that required highly skilled workers, builders started using smaller pieces of lumber that were cut into standard sizes. These pieces could be joined together using simple machine-made nails. Suddenly, building a house became much easier than before. A job that once took many weeks or even months could now be finished in only a few days. Even people without years of building experience could learn the method. This changed everything. More families arrived, more towns appeared, more houses were needed every year. The building method spread from one area to another until it became the normal way of building homes. As time passed, almost every part of the housing industry grew around wood. Lumber companies became larger. Sawmills opened across the country. Workers were trained to build with timber. Building rules were written with wood in mind. Banks created loan systems based on wood frame houses. Insurance companies understood how to insure wooden homes. Builders became experts at working with wood because that was the material they had always known. Allegedly, the system became so large that changing it later would become extremely difficult. Even if another material appeared, replacing wood would mean changing factories, training workers again, rewriting building rules, and rebuilding supply chains that had taken generations to develop. That would cost enormous amounts of money and time. Because of this, America continued building with wood year after year. The report suggests that the country did not continue because wood was always the strongest material. Instead, it continued because the entire construction industry had already been built around it. While this was happening, another story was beginning on the other side of the world. China did not follow the same path. Allegedly, one terrible event changed the way the country looked at buildings forever. In July 1976, a powerful earthquake struck the city of Tangshan while many people were asleep. The shaking lasted only a short time, but the damage was enormous. Entire neighborhoods were destroyed within seconds. Official reports said around 242,000 people died, although other estimates claimed the number could have been much higher.
A 7.8 magnitude earthquake struck Tangshan. The city was leveled, and 240,000 people were killed.
The disaster shocked the country. It also forced engineers and government leaders to ask difficult questions. Those questions would eventually lead China toward a completely different construction system, one that focused first on safety, then on strength, and later, many years afterward, would also open the door to another material that few people expected to become part of the future. That material was engineered bamboo. But before it could become part of the story, China first had to completely change the way it built its cities. The disaster changed everything. So, how did China turn that painful lesson into one of the world's largest and strongest construction industries? Let's learn more. China's concrete revolution opened the door for engineered bamboo. After the earthquake changed the way China looked at construction, the country allegedly decided that simply rebuilding damaged homes would not be enough. Leaders, engineers, and builders wanted a system that could protect more lives if another powerful earthquake happened in the future. They believed stronger buildings had to become the new normal instead of the exception. Because of this, new building rules were introduced across the country. These rules required reinforced concrete to become the standard material for most urban residential buildings. Reinforced concrete was very different from the older brick buildings that had failed during the earthquake. Concrete was combined with steel bars placed inside it before it hardened. The concrete could carry heavy weight, while the steel helped the building bend slightly instead of breaking apart when powerful forces pushed against it. Allegedly, this combination gave buildings a much better chance of remaining standing during earthquakes, even if they suffered damage. The goal was not to make buildings impossible to damage. The goal was to give people inside enough protection to survive. That lesson became one of the most important changes in China's modern construction history. But changing building rules was only the beginning. The country also needed enough materials to build millions of homes, schools, hospitals, offices, roads, bridges, and factories. Because of this, China reportedly invested huge amounts of money into cement factories, steel plants, and construction industries. Year after year, these industries continued growing. More factories were built, more workers were trained, better machines were introduced. New production methods made construction faster than before. According to the report, China eventually became the world's largest producer of cement, making about 57% of the global supply. The country also reportedly produced more steel than the next 10 largest steel-producing countries combined. Those numbers showed just how large China's construction industry had become. The country was no longer simply rebuilding cities. It was creating one of the biggest construction systems the world had ever seen. Another important change was the way buildings themselves were made. Instead of carrying out every step at the construction site, many building parts allegedly began to be produced inside factories. Large wall panels, floors, staircases, and structural columns could be manufactured under controlled conditions before being transported to the building site. Once they arrived, heavy equipment lifted the finished sections into place. This reduced mistakes, improved quality, and helped complete projects much faster. As more factories joined the industry, reinforced concrete became not only strong, but also affordable. The report even suggests that, in many parts of China, building with reinforced concrete eventually became less expensive than building with wood. This happened because the country's entire supply chain had been designed around concrete production for many years. Every part of the system worked together. Cement was available, steel was available, skilled workers were available. Transportation systems supported the industry. Building rules supported the industry as well. Everything moved in the same direction. While this system helped China build modern cities at an incredible speed, another challenge slowly began receiving attention. Allegedly, producing cement and steel also creates large amounts of carbon emissions. As countries around the world started looking for cleaner ways to build, researchers began asking whether another material could reduce pollution while still meeting modern engineering standards. That question naturally brought attention back to bamboo. For many years, bamboo had been ignored as a serious building material because natural bamboo had many weaknesses. It was hollow, uneven, difficult to connect, and could split or rot if not treated properly. However, researchers did not stop studying it. Instead, they completely changed the way bamboo was processed. Rather than using whole bamboo stalks, they crushed the bamboo into fibers, treated the fibers with special resin, and compressed everything under extremely high pressure and heat. The result was engineered bamboo, sometimes called bamboo scrimer. Allegedly, this new material removed many of the weaknesses found in natural bamboo while keeping many of its strengths. It became much stronger, more consistent, and more suitable for modern construction. This is where the story begins to come together. China's experience with reinforced concrete did not suddenly disappear because engineered bamboo was developed. Instead, the country's decades of research, strict building standards, advanced factories, and large manufacturing industry created the perfect environment for testing new materials safely. Engineers did not present bamboo as a complete replacement for reinforced concrete. Instead, they reportedly viewed it as another useful material that could work alongside concrete and steel. Reinforced concrete could continue providing the strength needed for foundations, tall buildings, and earthquake resistance, while engineered bamboo could help reduce carbon emissions in many structural parts where its strength was suitable. Because bamboo grows back in less than 10 years, stores carbon while growing, and can be harvested again without replanting, it offers environmental advantages that concrete alone cannot provide. According to earlier reports, China has already begun using engineered bamboo in buildings, bridges, and other structural projects, showing that it can carry real loads while supporting cleaner construction methods. In many ways, the country's construction story has continued to grow instead of changing direction. It first learned difficult lessons about safety. It then built one of the world's largest reinforced concrete industries. Now, allegedly, it is using that same engineering knowledge to develop materials like engineered bamboo that may help make future buildings both safer and more environmentally friendly. Rather than choosing between concrete and bamboo, China's construction industry appears to be searching for ways to use the strengths of both materials together, creating buildings that not only protect people, but also reduce the environmental cost of building the cities of tomorrow. What if the real story isn't just about stronger buildings, but about an entire country preparing for a very different future? Let's find out. China's insane future construction. China is allegedly moving very fast in building a future powered by artificial intelligence. Instead of improving only one industry, the country is bringing AI into almost every part of daily life. Reports suggest that AI is now helping with transportation, healthcare, farming, education, construction, shopping, security, and manufacturing. Rather than waiting many years to introduce new technology, China appears to be developing many projects at the same time. Supporters believe this approach could help the country become one of the world's biggest technology leaders. The goal is not only to build smarter machines, but also to create a system where those machines work together to make everyday life easier and faster. One area that has already seen major changes is food delivery. Companies are allegedly using drones to carry meals through the air instead of sending drivers on motorcycles or bicycles. These drones follow planned routes and deliver food to special collection points. Reports claim they can complete many deliveries in only 15 minutes. Larger drones are also being used to transport heavier goods to villages where normal delivery services may take much longer. Transportation is changing just as quickly. Reports suggest that millions of new vehicles now come with intelligent driving systems that can perform many driving tasks on their own. These vehicles use cameras, radar, sensors, and powerful computers to understand the road around them. Some models can park without help, avoid obstacles, recognize traffic lights, change lanes safely, and even drive themselves to meet their owners after receiving a voice command. Other electric vehicles have introduced unusual features that were once seen only in science fiction. Some can turn around in one spot, move sideways into very small parking spaces, or even float on water for a short time during floods. Electric supercars have also become faster while using advanced suspension systems that allow the vehicles to jump slightly, lift individual wheels, or move in ways that almost look like dancing. Battery technology is also improving. Reports claim that some new charging systems can provide hundreds of kilometers of driving range after only a few minutes of charging. This could make charging electric vehicles almost as fast as filling a car with fuel. China is also investing in high-speed rail. Magnetic levitation trains, which float above the tracks using magnetic force, have reportedly reached extremely high speeds during testing. If these systems continue to improve, they could reduce travel times between major cities and make long-distance travel much faster. Artificial intelligence is also entering classrooms. According to reports, children in Beijing are now learning about AI from a very young age.
China is investing heavily in AI technology, and not just in gadgets and software, but also in the education sector. Artificial intelligence technology is becoming increasingly prevalent in classrooms across China.
Schools are introducing lessons that teach students how intelligent systems work so they can prepare for future jobs that may depend heavily on technology. Construction is also changing with automation. Reports suggest that China is using self-driving trucks, intelligent road rollers, and automated paving machines to build roads with very little human control. These machines use satellite guidance and smart computer systems to improve speed and accuracy while reducing mistakes. Public transportation and airports are becoming more automated as well. Facial recognition systems are reportedly helping passengers move through airports without showing tickets or identification cards at every step. Cameras automatically recognize passengers and allow them to continue through different checkpoints. Similar technology is also being used in public security systems. Large camera networks reportedly help authorities recognize faces, locate wanted suspects, and improve public safety. Some police officers also use smart helmets equipped with artificial intelligence to help identify people during patrols. Shopping is becoming easier through new payment technology. Reports claim that people can now pay for goods simply by placing their palms over special scanners. The system reads the unique patterns inside the hand instead of using cash, cards, or mobile phones. This technology has already been introduced in many stores, schools, and transport systems. China is also making major progress in robotics. Humanoid robots have been developed that can walk, run, carry objects, dance, respond to voice commands, and help with simple daily activities. Robot dogs have also been created for work in factories, public events, emergency response, and security operations. These machines use advanced sensors and artificial intelligence to move safely while avoiding obstacles around them. Another growing industry involves highly realistic human-like robots. These androids are designed with detailed facial expressions, artificial skin, blinking eyes, and natural conversations. They are reportedly being used in museums, hotels, schools, and government buildings to welcome visitors and provide information. Healthcare is also benefiting from artificial intelligence. Hospitals reportedly use robots to deliver medicine, assist doctors, and support patients. Robotic surgery has allowed medical experts to perform operations from very long distances using advanced communication systems. Some hospitals are also testing robot doctors and robot nurses that help answer questions, examine patients, and assist with daily medical work. Farming has also become more modern through artificial intelligence. Smart drones spray crops, spread seeds, and monitor fields, while automated farming machines help plant crops much faster than traditional methods. These systems use cameras, sensors, and satellite guidance to improve farming while reducing the need for large numbers of workers. Taken together, these developments allegedly show that China is building an entire technology system where artificial intelligence supports almost every part of daily life. Although some projects are still developing, and some claims may require more long-term verification, the overall direction appears clear. China continues investing heavily in automation, intelligent machines, robotics, transportation, healthcare, farming, education, and digital technology, with the goal of creating a future where people and intelligent machines work side by side across nearly every industry. What do you think about China's shocking invention? Share your thoughts in the comments section below. Thank you for joining us as we explored how engineered bamboo is changing the future of construction for China. If you enjoyed this story, please like and subscribe. Click on the next video to discover another fascinating story. See you there.